Okay, so again, just a couple more sections we're doing before we get ready for our exams. And this one again is a nice to know section, especially we're going to be talking about something called matrices today. And that's something that does show up from time to time on things like the ACT or in other places as well. It's something you will see in Algebra 2 if you take Algebra 2 as matrices, but we kind of usually skip over them in geometry just because we usually don't have time. So our warm-up question, guys, so a reminder that it says write the translation using the coordinate notation and vector notation. That's the two things we've learned so far. Coordinate notation is the one we learned the first day. That's where we did, it's more like kind of, I would say, elementary, where you write x plus or minus whatever it is, whereas vector notation kind of takes the x out of it, and we just look at it as just the a and b values, so without the x's. Oops, that should be plus or minus. So those two ways. Now, yes, do you have the right notes? Oh, I'm reading it, I'm sorry. Those are the ones.
No, wrong.
Sorry about that. Yeah. Okay guys, which shape is our original shape? Which is the first one? The lower one. So the ABC is the original. We call that the pre-image. And the new image is where we have those little, we call them primes, or it kind of looks like a little apostrophe. And that's important to know which one we're starting with and which one we're ending with. So talking about this in terms of the coordinate notation versus the vector notation. So I'm asking myself is what's happening to x each time? So my x coordinate, it's worth maybe looking at what this coordinate is. So I count over, I believe that's 6, -1. Now if this is a translation, I really only have to check one of the points. I want to see how much I moved in the x direction. So I moved it over, can you stop doing that please? I moved it over all the way to the left, so since it's left we're going to subtract. And we have 6 and then 3 more, I believe it's 9. Do you guys agree? Sometimes it's hard for me to count on here. I poke it and it ends up. So x minus 9. And then I would go up to the a prime. And that looks like it would be up 6 as far as I can tell. Do we agree? Yeah. And so that's considered coordinate notation, whereas vector notation would be -9, +6. So just being comfortable with those two notations, I could ask you guys for either one. Either one can be used in different places or depending on the problem. Okay? All right, so we're going to talk about something called matrices today. And again, matrices are something that from time to time we'll see these on the ACT. We'll definitely see them in Algebra 2 and maybe some more upper level math classes. But at the same time, it's really not that complicated of an idea. It's what you see on there. They kind of look like a little, maybe like a little grid, or I always say it looks like an Excel spreadsheet or a Google spreadsheet. And so it's something you will end up using in some phase. I mean, spreadsheets are used in a lot of different areas. A matrix is just basically a spreadsheet written kind of out, so written out. A matrix is a way to organize data. It typically is in a rectangular arrangement. Guys, make sure we're focused, please. So before we had, like, this makes me sound really old, but before we had like Infinite Campus to keep grades, I used to put everything into a spreadsheet. So I would have, like I would put, Miss Miller across the top, and it would say like what different grades she got on her assignments across the page. And if it was a 0, it would go in as a 0. If it was in as 100%, it would go in that way, and that my spreadsheet would calculate that. So an element would be one particular assignment. So if we're talking about a test and how she did on that one test, that's one specific entry in the matrix. So for example, like one data point, like your grade on a particular day, or like your pay at a particular date at work. Now the way a matrix is written is based off what we call dimensions. And just like anything that has a size to it, knowing that dimension is important. So like if you go into Home Depot and want to buy, you know, a piece of lumber, you would say I want a 2x4. You would give that specific dimension. You would just walk in and say like, where's the wood in the, you know, like I just need a like piece of wood in the department. You want to have that information. So the dimension is the size. And the way we show that is in our matrix, going across, we have rows. And we're going to put a little X, kind of like a 2x4. And then we also have columns. So again, this is what I'm talking about, like a spreadsheet, it's where we put all this information in. So when I say how big the spreadsheet is, it's how many assignments across how many students. That's how big the spreadsheet would have been for my grade book. So that'd be a lot of data. And so again, that's why we got programs like Infinite Campus and other programs like that, because that was a lot of data to keep in a spreadsheet. But spreadsheets are willing to hold that much. So for instance, like looking at these matrices down here, if I'm talking about, let's maybe just look at this one specifically here. We would say that this matrix is, we count how many rows it is. So the size of this matrix. How many rows does this matrix have, the one I underlined here?
3.
There's 3 rows. And then how many columns? There's 2. So this would be a 3x2 matrix. So someone who would know something about matrices would know what I was talking about when I said it was a 3x2. Okay? Now, a lot of the matrices we're going to deal with always are going to have a 2 involved, and I'll show you guys why that is in a little bit. Because they correspond to our graphing, but we're going to add and subtract these matrices. So, you're going to add or subtract the entries in the same position. Another important thing to know is you can only add or subtract matrices that are the same size. Okay, stop talking, please. It wouldn't make sense to add 2 matrices that aren't the same size. So adding and subtracting, pretty easy, because adding and subtracting is not a very difficult topic. It's not like we just learned how to do that. Why isn't this extending? I'm just going to do it a bunch of times now. So we're going to add and subtract these values, and I apologize if it's hard to see. But my new matrix is going to be exactly the same size, but I'm going to take the -4 and I'm going to add 1 to it. So -4 plus 1, like I said, sorry, this is not letting me. So that would be a -3 there for my matrix in my first slot. I have -2 plus a -5. So this is going to be a -7, and I don't put lines between them. I just kind of keep them separated a little bit. -3 plus a -3 would be a -6. And -1 plus a +1 would be 0. And for a 0 in our matrix, we would put a 0 in. Kind of like I said, Miss Miller has a missing assignment, so I put that in as a 0 so that I don't miss that value there. Now the next one we're subtracting, that's a little bit more complicated. Because in order to subtract, we have to think about the subtraction going to that second matrix. So I'm doing -5 minus 4. And again, I apologize, it's hard, I can't get it to adjust down. -5 minus 4 would be a -9. -2 minus 2 would be a -4. So my top row would be -9, -4. And I kind of just keep working my way down. So -1 minus 6. Sorry, so I got -7, 7, -9, -4. Let me know if you don't understand where I'm getting those numbers from. Okay? Oh, there, let me do it finally. Sorry. Apparently I need to turn the extend page option on. That's what I need. All right, any questions there? Now you might be wondering, what does this have to do with graphing? And so matrices do have a connection to graphs. And so the idea with the graphs is it's just a way to organize our coordinate points. So we'll get to that here in a second. So if you guys see this matrix, this EW, hopefully you guys would realize that what it's probably telling us is they're telling us the X and the Y. They're giving us these coordinate points. So for instance, our different coordinate points, this is 3, 5, it's 4, -2, -1, -6, and then -2, 1. So those coordinate points correspond to our matrix. And so it's a way to organize our information and make sure that it makes sense as we're doing this. Okay. So we're going to graph it. Here's our quadrilateral, so a four-sided shape. And it says, let's translate this left 2, up 4, and translate the matrix, write the translation as a matrix. So what we do with that is basically it's saying, what are we doing to each of the x's? Well, I'm going left 2. So I go -2 to each of the x's. And you might wonder why we make a whole matrix like this, but it would be telling me what to do to all these x values. And then going up 4, I'd add each 4 here. So if they write the translation as a matrix, this might be the way we write this. Can you please be doing this with us, please? So I'm going to take all these points, I'm going to move them left 2 and up 4. We have our new drawing here that should look the same size. It's just translated over and up. And so what I could do then is I could say I'm just going to add these two matrices together, and my final matrix would just be the answer of that. So my final, the image then, the new one, would be I take this matrix and I do 3 minus 2. And that would give me my final matrix of 1 for the first one. 5 plus 4 would give me 9. So I'm able to write this down by adding these matrices together. And it's just another way to check that I did things correctly, which now I'm worried about this one. Oh, that's negative 4. So our final matrix should be what the image is. So the final matrix, so over 1 up 9, there's my first point. 2, 2 is right here. Negative 3, negative 2, I've been too far over, maybe? Or I did something wrong. So my green one was supposed to be down further. So I'd drawn it wrong. Negative 4, negative, or positive 5. And so I was able to kind of check that I did my matrix correctly, and I fixed my drawing because, again, up here on my screen, or maybe you're counting, you miscounted. And so, again, that I could fix my drawing so that it looks more like the original. Okay? So a matrix can relate directly to our coordinate system. All right, the next couple of things we're going to talk about are how we can use matrices to solve some equations as well. So if you guys look at this matrix here, it's basically, it gave us a matrix that they're adding these two matrices together, and it equals this one. Now, some of this is unnecessary. Guys, let's focus, please. So 0 plus 3 equals 3. Okay, like I agree with you, but that doesn't really help me. I want to find x and y. So I'm going to specifically look at the parts that include x and y. So I have x here plus y is going to equal 18. So I'm going to write that equation. X plus 4y equals 18. Now, looking at that equation, I can't solve that one for x and y right now because I don't know enough about either variable. So I'm going to look at and see if I can find another equation. Make sure you're doing this with us, please. So our next one here is I have 2x plus y is going to equal 1. And we haven't done this for a little while, but this is systems of equations. So I have two equations with two variables. So I was able to pull that out of my matrix there. Any thoughts on how you guys want to go about solving this? There's a couple different ways. How could we solve for x or y? We use elimination or substitution. Anyone remember? We use the elimination, we probably multiply by something. Which one? By 2 to the top. I'd probably do a -2 just to get it to be the opposite sign. So I'm going to multiply the top one by a -2. 4 would also work. Oops, not -18, -36. So we multiplied by -2. So 1 minus 8 is a -7y. 1 minus 36 is a -35. So I got it down to just one variable by just doing that quick multiplication. I'm able to divide by -7, and I find out that x is 5. Right? Y is 5, thank you. So our y is 5, thank you. Once I know y, we have to go back and find our x. So I'm going to put it back into the blue equation. And so x would also be -2 this time. So we were able to find x and y using that system of equations and using our matrix. And then our last thing is something called scalar multiplication. And we'll use this tomorrow to help us to do some dilations and kind of enlarge or shrink a matrix or a drawing. And what scalar multiplication is kind of like distributive property. So thinking distribute, so it's like I'm distributing this in. It's multiplication. Everything's getting that -2. So scalar multiplication, not too bad to do. All you're doing is multiplying that -2 into everything. And in this case, like doubling it or maybe multiplying by a negative number, it's probably going to make that drawing, like it would make the shape larger, but it would also maybe flip it as well. The negative might flip the drawing as well. All right, questions at all? So I have a 9.2 worksheet for you guys that we're going to do here today.